Hello, this is the Level 2 Probability 2021 paper for walkthrough. Let's get right into this. Question 1. New Zealand is well known for its cafe culture, and the availability of coffee has increased significantly over the last 20 years. However, there is growing concern that teenagers are consuming more caffeine with potential negative effects on sleep behavior and performance at school. The school was concerned about this issue and conducted an online anonymous survey of 300 of its senior students. It asked if students drink coffee regularly at least 3 times a week and if they have any sleep-related issues. The results are summarized in the table below. Actually, we don't need this standard normal distribution for now, so I'll just make it very small for now. Okay, so we have this table right here, and according to the results of the survey, what proportion of the senior students drink coffee regularly? So we can look at this. According to the results of the survey, what proportion of senior students drink coffee regularly? This is asking for out of all the students in the school. So there are a total of 300 students in the school, and out of them, what proportion of these students drink coffee regularly? So we have this line which says how many people drink coffee regularly. We want a total of how many of them drink coffee. So it doesn't matter whether they have sleep issues or not. We just want the total number. So the total number of people who drink coffee is 122, and it's 122 out of the 300 students surveyed. So it is 122 over 300. You should follow your probability of drink coffee is equal to 122 over 300. What is the probability that a randomly selected student from the survey who has sleep issues also drinks coffee regularly? So we are selecting a random student who already has sleep issues, so we are focusing on this column. So we are selecting a random student out of the 143 students who have sleep issues, and so what is the probability that a randomly selected student from the survey who has sleep issues also drinks coffee regularly? Out of the 143 students here, 68 students drink coffee regularly. So probability of coffee probability of coffee with sleep issues will be 68 out of 143 students. Next question. Sorry, what has happened? Sorry for that. I hope there was nothing weird on that recommended. Jack looked at the data for students with sleep issues and noticed that fewer of them drink coffee regularly. He claims that this means it is less likely for coffee drinkers to have sleep issues than those who didn't drink coffee. Explain Jack's reasoning and justify why he is incorrect. Include appropriate calculations to support your answer. So basically, this is a bit annoying since we need to keep on flicking back and forth. So basically, what Jack's justification is, looked at the data for students' sleep issues and noticed that few of them drink coffee regularly. So there are 68 students who drink coffee regularly and 75 students who don't drink coffee regularly. And there are 68 students who drink coffee regularly and have sleep issues, and 75 students who don't drink coffee regularly has sleep issues. There are less people drinking coffee with regularly, so that's why that's what his justification is. However, what Jack is doing is only comparing the numbers instead of the proportions. He's just looking at how many students. He's just looking at how many students have sleep issues rather than how many students out of the students asked have sleep issues. So we want to compare the proportion rather than how many students have sleep issues. So probability of drinking coffee regularly. So let's look at what the proportion of drinking coffee regularly and sleep issues is. So 68 of the 122 students drink coffee regularly and have sleep issues. So probability of coffee drinker and sleep issue is equal to 68 over 122. Now let's compare this with how the proportion of people who have sleep issue out of the students who don't drink coffee regularly. So that's 75 students out of the 178. The probability of not coffee drinker. Not coffee drinker and sleep issue is was 75 out of the 178 students. So this is approximately equal to 0.5574, and this is approximately equal to 0.4213. Clearly, the proportion of coffee drinkers with sleep issue is larger. Than the people who don't drink coffee and have sleep issues. So let's write the justification. Jack is only the number of students with sleep issues where 5 looking at the with 75 students who drink coffee who don't drink coffee has ish is while 68 students who do have sleep issues. However, he is only looking at the I've already said that. Okay, I would say however, he needs to look at the proportion of students affected by proportion of students who have however he needs to look at the proportion of students who have sleep issues. Then 0.55 is greater than 0.42, so Jack is incorrect. It is well known that many of the popular energy drinks consumed by teenagers in New Zealand contain caffeine in even higher doses than coffee. The same survey also asked about the consumption of energy drinks. It found that 36 students who drink coffee. So I just turn off notifications. And that by teenagers in New Zealand contain. It is found that 36 students drink coffee, but didn't drink coffee, but did drink energy drinks. Only 7 of these students who drank energy drinks but not coffee had no sleep issues. So, 36 students didn't drink coffee but did drink energy drinks but not coffee. So it's a total of 36 students were there. Only 7 of these students who drink energy drink but not coffee had no sleep issues. So 7 of these students did not have any sleep issues. So all the columns have to add up to the totals here. So 54 plus 7, and this last column has to add up to 157. So 157 take away 7 take away 54 is in this box. That is equivalent to 96. So I just rub this out and write 96. This here is 30. Take away 7, which is 29. Then this here in this place has to add up to 143. So this is 46, and this add the total of this and this, which is 142. You can check that this, and this all adds to 300 as well. If there were 850 students in the school who don't drink either coffee, who don't drink either coffee or energy drinks, who don't drink either coffee or energy drinks, how many would be expected to have sleep issues? So let's assume this data is true. So let's look at this data and let's look at proportion of students that don't drink either coffee or who don't drink either coffee or energy drinks. Let's and out of these students who don't drink either coffee or energy drinks, 46 of them have sleep issues. So 46 out of the 142 students. So probability of sleep issue without coffee and energy drink is equal to 46 out of 142, which is equal to 0.32. So this is the probability of having sleep issues without coffee and energy drinks. So if there were 150 senior students in the school, this would 0.32 of them of the 0.32 of the 850 students would be expected to have sleep issues. So 0.32 times 150 is equal to actually I probably rounded too much here. I should probably round to 4 decimal places. So this gives 275.3. So 275.3. So we want whole numbers. So we can we usually round down. Although rounding up does, it appears in the marking schedule that rounding up will still give you the marks. However, you usually want to round down since you cannot have 0.3 students. So 275 students are expected to have sleep issues. Next page. A newspaper article claims that teenagers in New Zealand who consume drinks containing caffeine regularly are nearly twice as likely to have sleep-related issues as those who don't consume drinks containing caffeine. Discuss whether this school's new survey provides sufficient evidence to support the validity of the claim. So both coffee and energy drinks contain caffeine. So let's look at the probability of students who suffer from sleep issues. So probability of sleep issue with caffeine. So energy drink and coffee. So students who drink energy drink and coffee suffer from sleep issues. So we add these two terms together. Do I even have a highlighter? So we add these two terms together. Hence, so yeah. So we have 68 plus 29 students who suffer from from sleep issue with caffeine. Then we have 122 students and 36 students who in total who drink coffee and energy drink. So 122 plus 36. This is equal to 68 plus 29 over 2 plus 36. This is equal to 0.6139. Yep, so I forgot to mention, but you always would want to round to at least four decimal points with probability. Discuss whether this survey so probability of sleep issue with caffeine is 0.6139. And then let's look at the proportion of students who suffer from sleep issue without caffeine. This is let's see, it's blue now. Actually, no, blue is probably a bad color. I'm already writing in blue. So who don't drink either coffee or energy drinks, 46 students are here, and 142 students suffer from this. So 46 students out of the 142 suffer from sleep issue without caffeine, which is 0.3239. So we want to put this in ratio. So 0.6139 over 0.3239. So putting it into ratio. So we're looking at proportion of students who suffer from sleep issue, which is proportion of students who suffer from sleep issue compared with the proportion of students who suffer from sleep issue without caffeine. This is the ratio. So if this ratio is 0.6139 over 0.3239, which is 1.895. So this implies there's 1.895 times likely chance. It's a 1.895 times likely chance that students who drink caffeine will have sleep issue than students who don't consume caffeine. So this is what we found out. So the claim is who consume drink containing are nearly twice as likely. So you can go about two methods. You can say either 1.895 times is close to 2 times. So claim is valid, or you can say so you can say this. You can say 1.895 is less than twice. So claim is invalid. Either of them is fine. They discuss whether the school survey provides insufficient. But either is fine, but stick to one. Don't write either of them. Write one of these claims. Discuss whether the school survey provides sufficient evidence to support the validity of this claim. Discuss whether the school's... Okay, so anything is fine as long as you have yeah, as long as you have a valid comment. So, for example, this survey only conducted with 300 students. So this says the teenagers in New Zealand who consume drinks containing caffeine regularly are nearly twice as likely to have sleep-related issues. This is a claim. This is a survey made by a school. This does not represent the whole of New Zealand. So we can say this was only conducted with 300 students from a school and doesn't represent students in New Zealand. And could have had bias or there are other factors like, for example, using your phone. It could also could also have sleep related issues, so not only caffeine, so that has not been taken into account. So coffee other the factors other than cough than factors other than caffeine can also affect sleep issue, or like any valid reasoning. any valid reason with like um with that has like logical reasoning behind it, it is valid. So, and for this, I don't care about the text. For this question, so let me get. So this part, writing this, so calculating this and writing either this or this gets you 1E is the first E mark, that gets you E7, and writing any of this is the second E mark, which gets you E8. So this is all you need to do for excellence. Question 2. The use of plant-based milks in New Zealand has become much more popular in recent years. Cafes also now offer their customers a number of alternative milk options, such as soy, almond, or coconut milk. Jungwoo owns a cafe and has collected data of his coffee sales over the last few weeks to find out how much he should stock alternative milk products. 40% of his coffee sales were to younger customers. 1/4 of younger customers requested an alternative milk type. 80% of older customers ordered a coffee with cow's milk. Of the younger customers who ordered coffee with alternative milk, 50% ordered soy milk. Half of the older customers who ordered drink with alternative milk ordered soy milk. Find the probability that in this cafe is younger. That a customer in this cafe is younger and orders a coffee with cow's milk. So we can see that all the types of milk is dependent on whether the customer is older or younger. So this first tree be old and young. 40% of his 40% of his coffee sales were to younger customers, so 0.4 to younger and 0.6 to older. 1/4 of young customers requested an alternative milk type. 1/4 is just 0.25, so alternative 80% of quarter, so 0.25. 80% of older customers ordered a coffee with cow's milk. So, no, I did it incorrectly. This is alternative 0.25. So apparently 80% of older customers ordered a coffee with cow's milk. Cow, so 80% is 0.8. Of the younger customers who ordered coffee with alternative milk, 50% ordered soy milk. So 15% ordered soy. So 15% is 0.15. Half of the older customers who ordered a coffee with alternative milk ordered soy milk. So because soy, so number of alternative options such as soy, almond, or coconut. So it's either cow milk or the alternative milk. So the customers need to either choose cow or alternative, then choose which alternative. So we can just say this: after we see whether they are old, we just check whether they want cow or alternative. They only have 2 options, so we can fill out this by I got this 0.2 since the probability has to add up to 1, so 1 take away 0.8 is 0.2. Likewise, 1 take away 0.25 is 0.75. So half of the young ordered. So find the probability that a customer in his cafe is younger and orders a coffee with cow's milk. So probability of young and cow is and we just so basically how we find the probability in a probability tree is we just follow the line. So we just follow. We want young. So we want young and oldest cow. So we follow this young and then cow. We follow this line, and this line has 0.6 and 0.75. So we multiply this together. 0.75, which is equal to I apologize again. I have forgotten that this is that I switched the order around, so 0.6, so 0.4 times 0.75, which is 0.3. Find the probability that a randomly chosen customer orders coffee with soy milk. Randomly chosen customer orders a coffee with soy milk. So we can the only way we could end up with soy milk is when we end up as here or here. So we can follow the path here, 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 and here, 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 and add those together. So actually I'll just keep probability of soy is equal to 0.4 times 0.25 times 0.15 plus so 0.4 times 0.25 times 0.15 plus 0.6 times 0.2 times 0.5. This is 0.015 plus 0.06, which is equal to 0.075. Out of the customers who request an alternative milk, what percentage order a coffee with soy milk? So we need to calculate the probability of so out of the customers who request alternative milk, what percentage of ordered a coffee with soy milk? So we want to calculate probability of soy out of the probability of our alternative. So we've already figured out probability of soy here. We just need to find the probability of alternative, which is so it's just probability of alternative is just here and here plus this line in this method, and we just cut it off. We don't care about what comes next here. We want to cut it off here, so this gives probability of alternative is equal to 0. 0.4 times 0.4 times 0.25 plus 0.6 times 0.2. 0.4 times 0.25 plus 6 times 0.2, which is equal to 0.22. So probability of soy, probability of out equal to 0.075. With 0.22, which is equal to 0.3409. But we want this as a percentage, so we multiply this by 100, which gives us 34.09%. The probability that a randomly selected customer ordered an almond milk is 0.066. Of those who requested alternative milks, there were equal proportions of those ordering almond milk in each range, while the rest of the customers ordered a coffee with coconut milk. So how many times more likely is it for a customer to order coffee with cow's milk than coconut milk? So, so let's make the probability table again. So we have older, young. So the younger is 0.4, 0.6. Cow is 0.8. Out is 0.2. Then this splits off to either coconut, soy, and almond. There's also cow alternative. So 0.05, 0.25. This goes to soy, coconut, or this goes to soy, coconut, or almond. So we saw that the probability of soy is of the younger, so 0.15%, 15% ordered soy milk of the younger. So 0.15. Half of the older people ordered soy. Yes, then. Okay, so of those who requested alternative milk, there were equal proportion of those ordering almond milk in each age range. So let's let this almond milk equal to X here and X here. So, and the probability that a randomly selected customer ordered an almond milk coffee is 0.066. So if we hover here, I just really want, actually maybe this Yeah, here, and almond, plus here, and here. This will add up to, so probability of mint is equal to 0.066. So all of these routes will add up to 0.666. So 0.4 times 0.25 times x plus 6 times 0.2 times x is equal to 0.066. 0.4 times 0.25, 0.1x plus 0.2x is equal to 0.066. 0.22x is equal to 0.66. Divide both by 0.22. Which gives x is equal to 0.3. So we know that here is 0.3, 0.3. Then now all of here, and here all adds up to 1. So 0. Here is 1 take. This part will be 1 take away 0.1, 5 take away 0.3, which is equal to 0.55. Here is 1 take away 0.5, take away 0.3, which is equal to 0.2. How many times more likely is it for a customer to order a coffee with cow's milk than coconut milk? So yeah. So probability of coconut is equal to 0. We now take this route. We already used it. Here, and here, and here. So probability of coconut is 0.4 times 0. Oh, that makes me cringe. 0.25 times 0.55 plus 0.6 times 0.2 times 0.2. This is equal to 2 times 0.2. This is equal to 0.079. Then the probability. Wait, have we figured it out? Okay, no. So, and probability of cow milk is equal to 0.4 times 0.05 plus 0.6 times 0.8. Is equal to 0.78. So, how many times more likely is it for a customer to order a cow's milk than a coconut milk. So this is called the relative risk. So we have probability of cow over probability of coconut, which is equal to 0.78 over 0.079, which is equal to 9.873. So 9.873 times likely. This is 9.873 times likely for a customer to order coffee with cow's milk, then coconut milk. Times likely for order of cow milk, then coconut. This was in fact an excellence question. So if you got this question correct, you actually wouldn't have to answer this next question since this is a merit. However, you would not be told that, so I would not risk it. So the excellence part is correct value of x found. So if we found the probability of coconut, so if you found this, you would have gotten one excellence point, which is E7, and relative risk calculated and interpreted for probability of coconut compared to cow's milk. So if you wrote this down, you would have gotten another E, which gives you E8. If you got both of those, it'll give you E8. You just specifically write down what this number means. So just writing down 9.873 is not good enough. You need to specifically interpret this as 9.873 times likely for order of cow milk, then coconut. Kathy prefers to drink a flat white coffee with milk, but is allergic to cow's milk and dislikes soy milk. When she goes to a cafe for the first time, if it does not have an alternative milk, she orders a long black coffee with no milk. She finds this happens to be 30% of the time. She has found that out of the cafes that offer alternative milk, about 40% have both almond milk and coconut milk available. If the cafe has both almond and coconut milk available, she flips a coin and chooses either one randomly. Kathy has also noticed that if a cafe has only one non-soy alternative milk available, it is twice as likely to be almond as coconut milk. Overall, is it more likely for Kathy to have a long black and almond milk flat white or coconut milk flat white? So she has found that out of the cafes that offer alternative milk, about 40% have both almond milk and coconut milk available. Okay, let's just fill this part in. This part is 0.3. This bunch, it always has to add up to 1, so this is 0.7. Then this part will be 0.6. So she has found that if the cafe has both almond and coconut milk available, she flips a coin and chooses either one randomly. A coin has an equal probability of half landing on either heads or tails, so they'll both be half, so 0.5 and 0.5 here. Kathy has also noticed that if a cafe has only one non-soy alternative milk available, it is twice as likely to be to be almond is coconut. So if it is twice as likely to be almond is coconut, then we'll have 2 over 3 here and 1 over 3 here. Yeah, given that information. So overall, is it more likely for Kathy to have a long black in almond milk flat white or a coconut milk flat white? So probability of long black is equal to 0.3. That is given to us here, which is quite simple. But it is an almond milk flat white. Let's follow the word for almond milk flat white. So flat white is here, and almond milk is here, and so body of almond milk flat white is equal to 0.7 times 0.4 0.5 plus 0.7 0.6 times an almond milk, so 2 over 3, which is equal to 0.7 times 0.4 times 0.5 plus 0.7 times 0.6 times 2 over 3. This is equal to 0.42. Now let's look at probability of coconut milk flat white is equal to 0.7 times 0.6 times 1 over 0.7 times 0.4 times 0.5, which is equal to 0.28. Clearly, okay, and the biggest number out of these three is here. So hence Kathy is most likely to order almond flat white. Question 3. Okay, a cafe manager that notices that the amount of time a customer waits to receive their takeaway coffee varies. He collects some data over a week and finds that the mean time waited is 7 minutes, with an estimated standard deviation of 1.5 minutes. Assume that a normal distribution can be used to model the waiting time for a takeaway coffee at this cafe. So working end / or diagram must be shown. Find the probability that a customer receives a coffee within 5 minutes. So here is a normal distribution. So the mean is 7, and here is 5 minutes. And we want to find the probability that they receive it in less than 5, so this area right here. So probability of x less than 5. Okay, we're going to begin using the probability distribution table. So probability is x is less than 5 is, so basically this distribution covers the probability from here, from the center to a certain point z. So this is equal to, and this half is always equal to half. So it's equal to 0.5 takeaway. 0.5 takeaway probability of of 7 less than equal to x less than 5. This is equal to 0.5 take away, so z is equal to x take away mu over sigma. So I'm going to convert this into with the center as z with the center as with 0 and z equal to a certain value. So the center is, so the mean is 7, so that we want to convert where z is equal to 5 take away 7 over sigma, which is sigma, which is the normal, which is the standard deviation, which we're given is 1.5. This is equal to -1.333, let's check. So we want to see z is equal to 1.33, and the difference here is 3. So 0.4082. So probability of -1.333 then z less than 0 is equal to 0.4082 plus this tiny 3 plus 0.0003 0.4085. So probability of x less than 5 is equal to 0.5 take away 0.4085, which is, oh no, this is 5. This is, I am truly sorry. So this is 0.005, so 0.4087. So this is a 7. This is equal to 0.0913. You may just use your calculator. That is just easier. One day the cafe has 100 customers who order takeaway coffee over the afternoon period. How many of these do you expect to have to wait for between 8 and 10 minutes for the takeaway coffee? So here's the normal distribution. Is 7, here is 8, here is 10. I want this area right here. So this area will just be probability up to here to 10. Take away this probability of here up to, this is equal to probability up to 8. So this is probability that 8 less than x less than 10 is equal to probability of x 7 less than x less than 10, probability of 7 less than x less than 8. So using the normal distribution, this will just be, so probability of, so the median is 7, so we want the z value of here. We have 10 is equal to the x value, and we want to convert this to the z value. So so for here, z is equal to 10 take away 7, 1.5, which is equal to 2. Z is equal to 8 takeaway 7 over 1.5, which is equal to 0.6667. So probability of 0.6667 less than x less than 0 less than 2 is equal to probability of less than x less than 0.6667. Oh no. Probability that 0 less than x then less than 2. Take away probability of 0 less than x less than 0.6667. So this figure out this probability. So we want, oh, by the way, we transform this to z now. Sorry, I forgot about that. So z is here, so we want z equals to 2.0, 2.00, and then there's no difference. So z equals 0.4772. Take away. By the way, I recommend you to use your calculator here. I cannot show it to you here, but you should use your calculator instead of doing it by hand. However, knowing it to calculate it by hand is also a useful technique. So 0.66 let me just check something. Probability of 0.245. So we want 0.667, which is here. So 0.2454 plus the difference is 23. So this means 0.2454 plus the difference is 0.0023. This 3 means that the fourth decimal place, and this 10 means 10 times the fourth decimal place. So 13 is 13 of the fourth decimal place. This is equal to 0.2295. By the way, I did not recommend. My working is a bit unclear. I don't know. I think you should use a bit of a more clear working. So then 150 customers who order takeaway coffee over the afternoon period. So we have 100. So probability. So we want there are 150 customers who order takeaway. We multiply this by the probability of the customers that wait for 8 x for they wait between 8 and 10 minutes. So we found that this probability is 0.2295. So 150 times 0.225 is equal to 34.425. So, and we can't have like a half customer. So we usually round up. I mean, we usually round down. So 34 customers. The manager notices that when a particular staff member was roasted on 30%. 30% of the customers waited less than 5 minutes to receive their coffee. The mean time the staff member takes to make and deliver a customer's coffee is still approximately 7 minutes. The manager suggested this means that the staff member should be rewarded for good service. Use the facts above to calculate an estimate of the standard deviation of time taken to receive coffee from the staff member, and discuss if you agree with the manager. So, because this is a different staff member, we will have a different standard deviation. So, if probability of x is less than 5 equal to 0.3, this implies that probability of z less than little z, which we can find, is equal to 0.3. So we have x. So we want to find where the probability is equal to 0.3. So wait, let's see. Yeah, okay, so we have here standard deviation. Then we want this area. So we want this area is equal to 0.3. So this implies this area is 0.2 with this z value. So I want to find what the z value is. So probability of z less than z than 0 is equal to 0.2. So the probability is 0.2. So we find 0.2 on here. The closest number to 0.2 is this number, and the next one we go above 0.2. We always want to go with an underestimate, not an overestimate. So we pick 0.52, then the next number. Oops. Then the smallest number we can add, the biggest number we can add is 14. If we add 17, that'll be bigger than 0.2, so we do not want to have that. So which gives z value of 0.52. 0.524. This is so that, remember, this is in the negative. This is zeros. This so this is z equals negative 0.5244. So z is equal, and we have this equation: z equals x take away mu over sigma. So we know that the mean time is still 7, so that has not changed. So negative 0, and we have the z value 0.524 for any values in between here. So 0.524 is equal to 5, since is the normal distribution of 5 and 7. Take away 7 over sigma, which implies sigma is equal to minus 2 over minus 0.524. This is equal to is equal to 3.81 minutes. So with the comments we say this standard you can shorten standard deviation SD has this standard deviation is higher than the cafe is a whole. So basically higher standard deviation implies that implies that this curve will be more extreme, like this. So, and a lower standard deviation means the curve will be a lot more spread out. So, wait. So I got it the wrong way around. Lower SD is this, and higher standard deviation is this. So lower standard deviation has more at the center and less spread out at the ends, while higher SD is more gathered in the center, while it is more spread out widely. So actually, I should keep it. I will keep it here. So this SD is higher than the cafe as a whole. So they are less consistent with serve. So because less consistent with the serve time, because so highest SD means majority of the wait time will be in between here, but here is more spread out, so there is a more variety of serve time, so they will be less consistent. So hence there are more proportion of customers who wait less than 5 men, but there will be a higher proportion of people waiting longer. this is the justification. So, and discuss if you agree with the manager's suggestion. The marking scheme says, I don't think they should be rewarded, but yeah, up to you, I guess. This was an excellence question, so if you quickly calculate the standard deviation and so quickly finding this standard deviation and discussing what the standard deviation means. Higher standard deviation means more consistent, and lower standard deviation means more spread out. And comparing what that means is worth it excellence. So last problem. Some of the data that the cafe manager collected over the past weeks are shown. Figure 1 below. Calculate the median, quartiles, and interquartile range for the data in figure 1. So we can quite clearly see that data from figure 1. Here is so this line shows the median. This line shows that seems to be 8.5. That spider. There's like a spider right next to me. It doesn't matter. And this is 5. So this signals the lower quartile. This signals the upper quartile, and the difference between the upper and lower is the interquartile range. So this middle line is the median. So the median is 6. The lower quartile is 5. Upper quartile is 8.5, and the difference is 3.5. So for a normal model, cut the median quartiles figure 1 and find a normal distribution with mean of 7 minutes and standard deviation of 1.5 minutes. So a standard deviation will always have the property that the mean is equal to the median. So the median is 7. So then for the upper quartile and lower quartile, the upper quartile is this Z point, where this area is equal to 0.25. So probability of 0 less than Z less than 0.25 is equal. Oh no. Probability that is less than Z is less than Z is equal to 0.25. Let's find 0.25 on this here. So closest to 0.25 is 0.67. And what's the largest number we can add? The largest number we can add is 4 or 13. So Z value is 0.67. Six, 7, 4. Remember, and we have this equation: Z is equal to X take away mu over sigma, and we want this X value. We can rearrange to get sigma Z equals X take away mu. X is equal to mu plus sigma Z. We'll note that the median is 7 plus 1.5 times 0.674. This is equal to 8.01. So the upper quartile is 8.01. We know the Z value, and so the lower quartile is this negative Z value. So we just the opposite, and so when take away 1.5 times 0.64 will be the lower quartile, which is 5.99. So 599, and the IQ range is 8.01 take away 5.99, which is equal to 2.02. This is what we have. So calculate the median quartiles. Yep. At the start of this question, you are told to assume that a normal distribution model with mean 7 minutes and standard deviation for input 5 minutes can be used to model the waiting times for a takeaway coffee at this cafe. Is this assumption appropriate? Use the numerical evidence calculated in part I to refer to the center, speed, and shape of the data in figure 1 to support your answer. So firstly, let's talk about center. Let's discuss about center. So the center is so median of data six while but the median and mean for normal distribution is the same. So median of normal is 7. So the model doesn't fit. Having written this is merit, and to get this to excellence, you need to although the question doesn't ask, is you need to suggest a different normal. You need to suggest what's better. So saying a different normal distribution with mean of 6 might fit better. This is for excellence. Although this is an excellence comment, it is not required, but apparently if you add this, it does. It will get you to excellence. So looking at this graph, it is kind of goes like this. So and a lot of the data is more spread out, and more of the data is on here, on this side, rather than this side. There isn't many data here. If we, for bigger values like this, it'll be more obvious. Like, yeah, this is a lot more obvious, but this isn't too obvious. It's a bit harder to see, but we call this skew. If a data has a tail that has, where the more of the data is onto the left, and to the right has a bit of a tail, we say skewed to the right. This model seems to be skewed on the right. So another comment you could make about the center is a normal distribution has mean equal to the median with symmetrical distribution. This data is skewed to the right. To the right. To the right. So not so median unequals mean. This gets you mirror, and then to push to extent you must say hence data cannot be normally distributed. These are the comments on the note on the center. For spread, so for the spread, you need to consider the range of interquartile range, the range, or just the standard deviation. So if we look at the data, the interquartile range for the data is a lot bigger than the normal model. Because here it's a lot bigger than this. So the interquartile range is much bigger. Than normal than the normal distribution model. It's not bigger than the model. So the data is more spread out. So data is more spread out. So basically, so I said that the expected range would, so the expected range of a so basically the expected range of a model, it would be three times the standard deviation, so which is 3 times plus minus, since it could go both ways, 3 times 1.5 minutes, which is equal to plus minus 4.5 is expected range. But this is the expected range, but the range is from this is the expected range from the mean. So here is a standard deviation 7, and then so plus minus 4.5, so it's 11.5, and here is 2.5, the mean. So expected range is 2.5 to 11.5, while the actual range is 1.5 to 15. Why actual range is 1.5 to 15. So remember how I talked about higher standard deviation is more so lower standard deviation is more spread out, so actual standard deviation for normal will be small. So the actual standard deviation for the normal will be smaller. These are the comments for the spread. This expected range with 3 times the standard deviation. This is just a given rule. It's called the empiric rule. So the range for standard deviation for normal distribution is always 3 times 1.5. So range for normal is always the median plus minus 3 times the standard deviation. This is a key method to explain your spread and justify whether justifies your range of your model. So commenting on the shape. So the data is clearly not symmetrical. Cool. Symmetrical, but is clearly not symmetrical, which is expected from a normal distribution. Like going in more detail will get you to excellence. So it is skewed to the right. We discussed this before. Skewed to the right. And yeah. So and the peaks, there are peaks here and here. So it is skewed to the right. has multiple peaks brackets at 5 and 7 minutes. At 5 and 7 minutes. And the and also there is also a bit of an odd cluster here, which is not expected from a normal distribution. There is also a cluster at 15 minutes. So just commenting anything about the shape, like having more justification will get you to excellence. There is also a comment where you can say, normal distribution would go below 0, which is impossible in this context. Just anything that comments on the shape which has good justification will give you excellence. So from the marking schedule, it says at least 2 different valid comments comparing center spread or shape of the data to the expected model with context evidence explaining why the normal model is or isn't appropriate to this context. So from the marking scheme, this this will get you to a merit. This will get you to a merit. These are the merit points from what I'm reading. This gets you to a merit. And these will get you to a merit, and these comments will get you to excellence. Just writing anything that has quite a logical sense, it will be good, but these excellence points such as this empirical rule of comparing the data, this is very good. I don't particularly like how just adding this rule adds you to excellence, but write as much as you. The best tip is write as much as you can, commenting about the data, comparing this data with comparing this data with the normal distribution. And it is also noted that this comment can only get you merit. So yeah, commenting on the other clusters could also get you to excellence, but I'm not 100% sure what is required for excellence. Thank you for watching this video. And I'll see you guys later.